Hi, my name's Alan, and I'm going to be presenting a paper titled Investigating Human Response, Behaviour and Preference in Joint Task Interaction. And this is work done with Bart, Craenen and Petrick at Heriot-Watt University, and Sara, Dalzel-Job and Robin Hill at the University of Edinburgh as part of the Start Making Sense project. So the idea in this work was to kind of conduct a user study where we examine the human participants in interaction. And the idea was that it was going to be lab-based, but it's now going to be a website. And if you're interested in the website or the kind of system side, then check out the KEPS paper. So humans are not always entirely forthcoming with their feelings or opinions. So which can of course mislead a robot, and if a robot was able to perceive more of what was going on, for example, using the fact that their eyebrows or their whole face is showing that they're angry, then it might be able to change its path. So for example, in this case, noticing that possibly the spike pit is not the human's preference, and changing its path. We're going to perform a user study to examine the range of human social signals, affective responses and behaviour patterns exhibited during cooperative joint action. And at present, our website captures task interaction, video stream, sound and mouse position, so for basically mostly for post-processing. So does the participant look confused at a certain point, for example? And the task is an instruction giving and following scenario based on some previous tasks in a kind of similar vein. So it's a bike sharing task. So on the left you've got a wee picture. So if you're at the tree, for example, the system might say, "Oh, go to the cafe," or go to the house. There's kind of partial reports of where bikes are. And so in this case, the dotted line indicates the bike might be at the house or the cafe, and the agent's going to instruct the human around and provide explanations and clarifications. Okay. The study questions are: do unexpected situations lead to detectable user response? And if yes, does the reason why the situation is unexpected lead to different types of user response? So would it give us a clue as to why the particular response happened? Does the user's response change as the task progresses? So this is really important if we want to use it as a predictor. Does providing the user with explanations lead to improved confidence and trust in the system? Hopefully. Can simple user heuristics be used to explain aspects of the user behaviour? So things like, do they go to the nearest tree if there's two trees? The agent's behaviour is kind of underpinned by a partially observable planning model. So we solve the problem and get a contingency tree. So for example, move from the tree to the cafe. Is the bike here? Yes or no? If it is, then get it. If it's not, then move to the house, and now you know it's there. And at each of these states, there's one of these kind of templates attached, which has different kind of interaction cues. So for example, here, move to the cafe, and there's a pause, and then there might be some kind of elaboration or explanation, and then another pause, and then some kind of repeat. So the fixed pause is kind of used in two ways. So in the first sense, it's just used as a kind of lack of action proxy for uncertainty or confusion, and the user would benefit from some more information or elaboration or explanation. But it also allows us to kind of use that time in post-processing to observe what the user was up to. Were they looking confident as they moved? Did they look confused and sat unsure? What was the mouse doing? These kind of questions. So during interaction, we're going to introduce certain scenarios. So for example, ambiguous instructions. So in this case on the right, we've got a tree, and the instruction is move to the house. The user's unsure which house. There's two houses. And the system can elaborate with the house with the blue roof. And now, of course, the user knows what's going on. Of course, if the user at X can already see that the bike's there, then maybe that'll change their behaviour, and we're going to explore that as well. We're also going to look at situations like this in the bottom left. So if you imagine you're in the mountains and there's a tree up to the right somewhere, and the instruction is something like move to the tree. If the system has already kind of informed the user that they're moving towards the Western District, does that allow the user to disambiguate that instruction? Do they need the instruction at all? These kind of situations, what does the user do? What's their behaviour? And on the right, we've got a situation if they move from the mountain to the cafe, then there's two houses. So for example, if the instruction that the system has as default instruction is move to the house, then this will be ambiguous instruction. Does the user prefer to move to C instead? And continuing on from that in the kind of context of inefficiency, on this left side, if that tree route through C is actually much less efficient as the crow flies, then what's the user's response, and does a kind of simple, oh yeah, it's a bit longer, but it's easier to explain, that kind of explanation, does that help? And in this case, if the system is kind of saying go to the greenhouse, and the user can see that the bike's at the blue house, if the system offers initiative, is that useful? So just a quick demo. The agent's on the top left, a kind of indication of what's being captured. It's on the bottom left. The map's in the middle. This is debug mode, so you can see all the locations. Top right is the legend. And the first clip is going to be the kind of basic information level, and then the second clip is just with a bit more information. Okay.
Go to the pub. Go to the pub. Oh well, that was not the one I meant. Go to the warehouse. Go to the pub. Go to the distillery. Pick up the bike at the distillery. Great. Hi, so you've got some bikes to find. I can help, just follow my instructions. We're trying to pick up the Western District bike. Go back to the cafe. Go to the tree. Go to the house. Go to the house. The red one. Pick up the bike at the house. Great.
So in conclusion, we're hopefully started performing user study to investigate human response, behaviour and preference in joint task interaction, and it's online, and we're capturing video stream, audio, mouse position and interaction. We've presented the kind of design of the study in this talk, where we're going to basically vary what information the user has at each point to make their choices, and then we're going to observe what they do, what their face does, what noises they make, and what their mouse does. And we're also going to collect lots of survey data, and the idea is basically to put it all together into a more informed planning agent that utilises some of the lessons that we've learned. Okay, thank you.